she's in Pune, Department of Zoology, and I know her since long time, since BHU. So she did a PhD from tumor immunology from Banaras Hindu University, and she's also a visiting scientist in Department of Internal Medicines, Japan, since 1994 to 1995. And she moved to BHU again from 1996 to 2004. And currently, now she is in Pune, and I invite you to further this wonderful talk.
Thank you. And I think Professor Natarajan has set the stage with the host and pathogen interaction with mycobacterium as the pathogen and macrophage as the host. I will be speaking on another pathogen, which is a eukaryote, and it also chooses macrophage as its host, that is Leishmania. So we have similar kind of story, but a different kind of pathway. So I hope TH1, TH2, all the angles are there. So I'll tell you in a different way. So we have used pharmaceutical or nutraceutical, as you say, which has been taken since long in our Indian scenario, that is Boogaloo. It's used for reducing cholesterol. So we found in the literature that generally Leishmania uses cholesterol for infecting the macrophages. It starts taking that. So we thought, why not we use Boogaloo and see whether it will, as an adjunct therapy, because many of the drugs have failed in the clinics, and physicians are on the lookout for alternatives, and there are no vaccines available, which is going out of hand. So visceral leishmaniasis, it's a vector-borne disease spread by sandfly, and the prevalence is mainly in the poverty-ridden areas of India, northeast India, and it has even come to the northern eastern part of Uttar Pradesh. And visceral leishmaniasis is characterized by fever. It is called as Kala-Azar, that is the mad fever. And if people are untreated, they develop pigmentation, that is why Kala-Azar. So it's found in almost 3 continents, as you can see here. And Muzaffarpur in Bihar, in India, is the epicenter of visceral leishmaniasis cases. And here you can see in India, these are the foci. And predominantly this is the area, hyperendemic area, and this is the Indo-Gangetic plains of Bihar, where we have hyperendemic places. So you can see here, these are the different manifestations of the disease. And this is most, it's causing a headache, it's a problematic issue for India now, that we have visceral cases decreasing and with an increase in the dermal cases, because now it has been hypothesized that the parasites, they are under the drug pressure, so they are escaping the viscera and going to the dermis. They are becoming dermatotrophic to viscerotrophic, and it's very disturbing to say that, and humans are the reservoirs. So sandfly will give direct load of parasite from man to man. That's a problem. And if they are present all over the skin, then the parasite bite is loaded with Leishmania parasites. So now Government of India and the WHO has been focusing on PKD cases, how to reduce it. So this is the, as per CDC, sandfly host and the human host. There is a vicious cycle going on between these two. So what is the hypothesis based on that? Existing drugs have serious side effects, and there is a time when the parasites become resistant to these drugs. So there is a need for alternative drugs because there are no viable vaccines till now, and they are in the nascent stages. So we took the Boogaloo, and as a control we use statins because those are used as anti-cholesterol drugs, and which have given several results on macrophage cell line as the host and the Leishmania strain. And here in the in our study, the main is we have used clinical isolate, that is the amphotericin B resistant, because amphotericin B is the only drug which is successful in the clinics now, which attacks the aldosterone in the membrane of the parasite. So we have chosen this amphotericin B, and this is our one plant. We have taken the blue, it's a gum resin of Commiphora vitae, and we have isolated. This is the way we done. First of all, we saw the hemolysis, because as per FDA, have to check whether the drug is toxic or not. We used the hemolysis, human RBC, and PBMC, and we found out the IC50 doses, and then we look for the direct cell killing. We have used two strategies: direct parasite killing and intra-macrophage clearance of the parasites by giving by treating the macrophages with the drugs. That's prophylaxis, we call it, in vitro, and we infect the macrophages with the parasite and then treat with the drugs, so that we call it as therapeutic in the in vitro setting. So here you can see we did the chromatogram, and we found that it has a standard glucosterone, which is the predominant molecule, and this is these are the results which shows that glucosterol extract showed very less cytotoxicity, which was not significant to peripheral blood mononucleosis, and hemolysis was very negligent. So it was safe to say that they are not toxic. Then this shows, and LDCI is the clinical isolate that we used, and these are some of the values for IC50, and AG83 is the WHO resistant WHO reference stream. And so we could see these are the IC50 values using atorvastatin. Then we checked by different pathways, leishmanian healing pathways using NMC and PI. And here you can see Google, as compared to the amphotericin B, it causes 18.88% apoptosis and 61, so which was quite significant as compared to the standard drug. Then this shows the with the AG83 comparison. And we also checked, because one of the method of killing is the generation of ROS in the parasites. And again, you can see here, we compare, this is the clinical isolate, which is already resistant to amphotericin B, but when we use Google, it showed almost more than the amphotericin B. And these are some of the parameters for parasite killing, that is the loss of mitochondrial membrane potential. Again, you can see the treatment of Google, how significant it was as compared to the amphotericin B. So we checked the growth arrest also, and here you can see Google also renders growth arrest to the leishmanian parasites. And for the reference tree, then we estimated the ergosterol in the membrane of the resistant isolate and the AG83. And you can see these are the estimates of the ergosterol content and how our treatment suppresses the ergosterol content if we treat with Google and amphotericin and what atorvastatin. And we did some of the STM images, because why we have to do, because the shape of the parasite is very necessary in order to enter the macrophages by the complement receptors. So they have to be spindle shaped with a lot of flagellar movement. So here we can see here, this is the control, and this is the treatment with Google, and this one, Google, and you can see at IC50 values, it has made them puffed up, and the flagella almost is lost, and IC90 values almost destroyed. So conclusions that they were indeed, it is effective in direct cell killing. Then we focused on some of the proteomics using swab-based differential proteomics, using amphotericin B and Google. And this is the proteomics workflow for both AG83 and the clinical isolate. And we were able to identify about 880 proteins in AG83 and 1944 proteins identified via the proteomics. And these are some of the workflow for annotation of uncharacterized proteins. One of the fallout was that we were able to find out several, because still the Leishmania don't know any strain has not been fully characterized genome, whereas L major has been characterized, which is a positive agent for cutaneous leishmaniasis. So total number of proteins identified, and these are some of the upregulated and the downregulated proteins. And some of the, when we did gene ontogeny studies, we could find in the isolate that most of the proteins were related to molecular function and biological processes which were upregulated and downregulated. That was mainly on the molecular function. So now we are trying trying to validate by using different assays. So these are some of the hub proteins using in the AG83 here, and in the clinical isolate, 19 hub proteins and 12 hub proteins were using amphotericin B and Google treatment. And when we did all the analysis, we could find that most of the proteins, they were ribosomal proteins, and enzymes for purine biosynthesis. They were significantly downregulated on treatment with Google. And we did some of the DEP pathways and cellular process analysis, and we tried to correlate the assays and the DEPs identified, and we could find that some of these pathways, they were inhibited by this thing, and which are very important for its pathogenesis in the macrophages. And we did several annotations of the uncharacterized proteins in this clinical isolate, and we are trying to validate, because these are just predicted at the moment. And we also did some of the gene ontogeny, which was very different, because over the years, the reference strains as given by the WHO, if you culture it more and more, they lose their virulence. So it was very relevant to use the clinical isolate and do the further processes. And we did several annotation, and we could find some of the cold chain changes in the proteins, and these are some of the functions attributed to these different proteins that were identified in our proteomics. And what are the conclusion? Main conclusion drawn out of the study proteomics was that upregulation of these antioxidant enzymes and ATP binding acid superfamily and proteins like ribosomal proteins, purine bisomal, these could be potential drug targets. This was one of the fallout of the study. So next we used macrophage, which is the main exclusive host of Leishmania parasite, and they are important in this thing, and they elicit an immune response or enhance, because TH1 and TH2 cover. What we are looking here is TH1 pathway, which should be pro-inflammatory, and interferon gamma, especially, as you said. So somehow again, when the Leishmania enters the macrophages, it prevents the phagosome from meeting the lysosome. This is the story, and people are working out on that. So this is the workflow. We took THP1 monocyte, we differentiated into the macrophages by PMA, and we checked the cytotoxicity. Then we labeled here we used cytochrome safe state for labeling because unfortunately we lost the GFP labeled Leishmania parasite. So we chose this pathway, and this is an indicator, because we could see the intramacrophages Leishmania parasites by flow cytometry. And we used DAPI stain, and we used confocal imaging, and these are some of the cytotoxic treatment, and we chose the IC50 same one, and we checked the ROS level in response, because reactive oxygen species are one of the arsenals of macrophages for killing intracellularly. And we could see different, we did kinetic studies, and we could see that this is the Google was very, very effective, as especially the 6 hours treatment was very effective in generating the ROS. And then we evaluated the nitrite levels also, and again we found the same kind of response, that it led to the production of high nitrite levels, which are Leishmanicidal. And then we established the macrophage and Leishmania infection ratio, because those are very important for in vitro studies, 1:10. And even when we give when we use the mouse models, we have to choose the right number of parasites to be given by the tail vein. So here you can see the confocal images of the macrophage infection. These are the cytokines labeled parasites in the macrophages. And we could see the prophylactic effect, that it was indeed rendering the macrophages Leishmanicidal when we treated the macrophages with the Google and atorvastatin and amphotericin B. Here you can see that Google was very effective in keeping the infection in control. And again, the therapeutic also, there was significant effect as when we compared both prophylactic and therapeutic. Indeed, Google was Leishmanicidal. And then we compared the prophylactic and therapeutic effect. Here you can see Google as compared to the control. We use cholesterol also, because generally the parasite uses the cholesterol for on making its own membrane in order to fight out all the reactive oxygen or nitrogen species of the macrophages produced. So here you can see these are some of this is the control where there is no parasites are there. This is the control with macrophages infected with the parasite. You can see the L-Dominant bodies. These are the antibodies. And this is the where Google treated. We have this one shows the cholesterol treated, because when we treat with the cholesterol beta cyclopentine, so it is not able to clear the parasites. So these are some of the we used for Nile red stain for cholesterol, and we can find that it could not, because wherever you see Nile red, it is surrounding the mastibode ridden the vacuoles full of mastibodes. So Nile red means it's an indicator that is trying to draw the cholesterol for its own. So some total, because I want to sum up because of the shortage of time. So our finding said that when we compared prophylactic and therapeutic potential, it pointed out a significant reduction in the inflammatory parasite infection when we treated it with amphotericin B, Google or atorvastatin. And this also showed an increase in parasite load that indeed it proves that cholesterol is one of the pathways for the infectivity of macrophages. That's why taking Google can help. It can be an adjunct therapy while using lipids. So it can be used in combination. That's what our message to the physician community is. As we are in collaboration with Mr. Shyam Sundar, who is one of the global heads of the Kalaza Research Laboratory in the WHO and its field site in Bangalore. So in future, because now there are a lot of cardiovascular problems which are attributed to increase in cholesterol, bad cholesterol, whatever. So people are taking this in from Vaidyas and all that. They have to be used in a very specific way. So that's what our message to the community, physician community is. So I will give thanks to all my students, especially this is the PhD, one of the part of the PhD work of Dr. Chinmay Pai, and I'm very thankful to all my collaborators, Dr. Mahesh Kulkarni, who helped us in doing our proteomic study from NCL, Dr. Sangeeta Samat really helped us in doing all the bioinformatics, because bioinformatics is out of we are trying to learn bioinformatics slowly now, and Professor Shyam Sundar, who gives us the strains, and we are in contact with him, we are correlating the status of the patient, how they are responding and all. Dr. Saha from Ancestors, who is also a traditional nephrologist, and my funding agency, Sir Venkat Sinha, and all my students who are in this. Thank you so much.
These drugs as adjuncts, it is better to use them as in combination with standard therapy. We showed nice exciting data on Google and avastatin, which the avastatin being the standard. So typically, like when you go to it's based on experience and what they talk about that when you are adding a new thing, it is always as a combination. It is not, ethics will not allow you to replace it. So in fact, it may be advantageous to you simply because then you can bring down the concentration of avastatin as well as this. You can have a synergistic. Absolutely. So you may have to standardize, but then you can have lesser IC50s can be more, MD50s can be even lower, and since all these drugs have side effects, avastatin side effects could be also low. Second part is that most of the work is ex vivo, that is in either THP1 or let's say mouse-derived macrophages. One of the problems, and I think the best example is curcumin. Curcumin works wonders in cell line systems. The moment you give it in vivo, the bioavailability becomes a major issue. When you're talking about, let's say, a herbal drug like Google, then it has to be given oral. No ethics will allow you to give it intravenously, right, or as an injection. So when you do Google what is the PK/PD levels, those studies you may have to do. Best example would be to infect mice and then give these as oral drugs, avastatin as a tablet. That's what we did with our amlodipine, that we infected guinea pigs and then gave the treatment. So we did a lot of standardizations. In fact, because we wanted to give how much will it take. So we measure how much water a guinea pig will take per day. So then adjusted the concentration in that water bottle and ensure that it goes. So for 10-15 days we just measured the PKPD levels. So you may have to do a little bit of this, but very nice.
I'll just respond to it that because this was one aspect of studies. So if it can work effectively, so this will be done by other students.
Root of thing.
Yes. And the other thing is we are Dr. Bhaskar Science and SSL. He has an animal facility.
I know Bhaskar.
Yeah, and a lot of knockdown, all the so we are working on from that. Thank you so much. Yeah, you have just spoke our mind. Thank you.
Cholesterol, if cholesterol is there, it will not be clear. And there can never be no cholesterol in the immune system. So what would be the efficacy of the treatment if I use it in an immune system? Will it be able to clear the
Because membrane cholesterol is always there. There's a balance between that.
So how
So
will
it
it
is taken up by the spleen macrophages. There is a lot of pathway. It's not direct contact. It has to go via the skin when the sandfly bites. So it is taken up by those neutrophils. They die. Then the macrophages are cleared, and then it goes into the macrophages, goes into the lymph nodes, goes to the liver, bone marrow, spleen. There that's why spleen, hepatospleen began, and then via that. So there's a huge complex pathway. As you said, it's very simple to say this. But what exactly happens? So, by using marker or person dye or imaging studies really will help in.
Do we have a zebrafish model for this?
Yeah, that will really.
But do whole body imaging.
But there are very less. We have hamster, guinea pigs, hamster model, and there are not good animal models because it's a very complex kind of parasite. It's eukaryote, it's very simple. And we need sandfly bite for getting natural infection.
So, wonderful talk. I would like to ask one question. You work on Barwani. So, these are the samples, you have taken a culture one. What you have done is you have similar results when you have taken a clinical patient from patients?
Clinical patient here, what is the highlight of the study is that this clinic, the isolate from the clinical patient, he has relapsed to amphotericin B in the clinic. So that's the main part. And the clinical data is showing different story, but when we are using in the in vitro, it is showing different story. The IC50 values are different.
And what happened to this whole structure, because it's a flagellated one? So where is really destruction is taking? You say 100% parasite is destroying, but is a particular
IC90 values we could see, but not with amphotericin. And shape is very important. So that's why
so shape is not changing at all. In when you have a high treatment of people.
It is changing.
Okay, so
why we are saying, because when it is there in the circulation for a brief amount of time before going into the macrophages. So if you take a full of any drug, it is under the influence. Will it damage that? It will prevent the influence.
Any other question? Yes, please.
Yeah, I have not shown gene expression studies. I have not shown TH1, TH2 pathways. So there are a lot of studies, but I just highlight.
Because they have to pinch the ROS production.
Yes, I am not sure. Please down. But in the Google, we came back to the result. Thank you.
Felicitate Professor Kalpana Pai for delivering such an outstanding.
Sir,